Welcome to the MMED class on data management and cleaning in R, calling it data wrangling in R. The main purpose of this lecture is to introduce some principles of data management, and I'll refer to them as tidying, which is a way of structuring data sets to facilitate analysis. And then the second key thing is to introduce you to practical and modern tools in R that we use for data wrangling, particularly one package of that's referred to group of packages called TidyVerse. And then I would like to also share some examples on how to wrangle data. And hopefully this lecture is obviously really important for you as you wrangle your data, both for MMED project, but also for your day-to-day working on data. So let's start with the principles of data management. Anytime you've got a data set as an analyst or as a modeler, the key goal of your data management is to get your data in R in a useful form that you can use it for visualizing or analyzing. And it's sort of a process. So data needs to be organized, data needs to be cleaned, you need to manipulate it, you need to put it in a form that eventually you're able to analyze. And in fact, a lot of experiences with data management is people spend maybe 80% of their time on the processes prior to analysis, the manipulation, cleaning, and 20% of the time really on the actual data analysis. It doesn't take too long once your data is in the right format to do the appropriate analysis for it. So an investment in the skills of data management or data wrangling through R are really important. I provided a nice diagram here that's borrowed from Handel Wickham on the life cycle of a program or a project. So you have got your data sitting somewhere, you import it, you spend an amount of time manipulating it to make it tidy, and then you transform it, visualize it, and model, and that's a cycle before you can communicate your results. I think that an investment is important, otherwise you do it over and over, and that is not a good use of time. So this concept of tidy data, I head back to a nice article written by Handel Wickham in the year 2014. And the idea that's sold in this paper is having a consistent way of storing data that allows for easy manipulation and also analysis. And I will show you in an example what that means. So it's based on a few rules. So one of the rules is that each column of data will be a variable, something like a country, it could be gender, it could be age, it could be infection status. So variables, each column is presenting a variable. The other key important thing about tidy data is that each row is an observation. So imagine you are having a study that has 10 people participating. So data about each person will be on a row, and on columns you have their age, you've got their sex, you've got their education level, you've got their income status. All those will be columns, and then the rows are representing data of a single person. The third part is that each cell, and that means when you've got a row and a column, that one cell is a value, and those are the values that we have a big interest in. That's how a tidy data set would look like. But obviously, it's to give you a really good example is this data that you're going to be using for some time in this lecture, or a study we did a while back, which was looking at cattle in their first year of life. And the idea was that we wanted to find out what's the full burden of infectious diseases that these animals are exposed to in their first year of life. And to do that, we recruited over 500 animals, and each of those animals was examined every 5 weeks up to when they got to a year old. And in each of those times, we knew when the calf was born, how old it was during that visit, what was the weight of the animal, and did it have a number of infections, some of which I have presented in this data set here. And that is Theileria and strong gel eggs, which are worms and a protozoa and parasites. So this is a tidy data set in that each of the rows, each of the columns represent a variable, age, weight, infection status, and an identifier of the calf ID. And each of the rows represents data about each of the many 500 calves that we did. So in this example here, you see a calf that is calf number 28. That is visited at this time. It's 3 days old. It was 19 kgs at 3 days old and did not have this specific parasite, and this was not done. If you take the example of calf number 36, 6 days old, 48 days old, 77, 112 days, those are the number of times you visited it, and its weight was 15, 20 kgs, 29, 34, and had no infection of the Theileria species, but it had a number of eggs that were counted. That's a tidy data set. An untidy data set of the same data set would look like, so you have got the age in days, what I was showing you, the 3, 6, 42, 77, each of them appearing as columns. So you have like calf number 36 would be 15 kgs at day 6, at day 42, 20 kgs like that. Now the problem with this kind of data set is that you imagine now if I add in information about the sex of the calf, if I add information about the infection status of the calf, and you can see that data set becomes really pretty difficult to deal with. But it's also notable that it might be easier sometimes to analyze data that looks like this. So if you're interested to look at, say, weights of animals that are 42 days old, then a setup of this kind of data set might be good. But in the principles of tidy data sets, you would want to have a variable in each column, and then rows representing each individual. Okay, so I sort of got to the level where you have some principles of tidy data, but now I want to focus on what available tools are there for manipulating data, which you should be able to use easily. So one group of packages is referred to as TidyVerse, and it comes with many loaded packages once you install it. So it has TidyR, it has dplyr, it has ggplot that you use for for plotting and making graphics. You have got readr, you've got Tibo, you've got a number of those. But for today, to introduce you to this package, I would like to give you examples using pivot longer, pivot wider, which are all just wider, which are all functions within TidyR. And there are more. Within dplyr, you have select, filter, group by, summarize, arrange, join, mutate, and all those might sound like they are. I mean, you don't know what the functions do, but in a short while, I'll give you examples to just show you how well we are able to deal with data sets based on that. So to recap, first of all, that you want to make your data sets tidy. You want a variable which measures a value of the same attribute across observation units, like the examples given of weightage, infection status, and that variable is equal to a column, and then observation, which is a unit of like a person or an animal, and that observation is given as a row, and then within a row there are observational units which forms, and when you have that together, that forms into a data table or data set. So let me introduce you to this TidyVerse if you haven't used it before, and I'll do that by I'll switch over to my RStudio and see whether we can do this together. Okay, share my screen, and I'll go to my RStudio, share right there. Okay, so one of the things that we can do, so what I've done is that these notes I've made them in an RMD. So I'm going to just share the codes that are within the RMD as we go through the notes of the day. So I mentioned that the first thing you need to do is you need to install TidyVerse if you don't have it. But if you have it, you just need to do, you just need to have library TidyVerse. So that's how you would install TidyVerse. But because I've got it, I'm going to ignore it. So I'll do library TidyVerse. Sorry, I made an error there. So it needs to be library. There you go, which is the same as sending this. And then within in the working of TidyVerse, you need another package called MMED2021, which would be providing us a specific function that is called piping, which I'll show you in a short while. And if you want to work with dates, another really nice package would be Lubridate. So, so I've got data sets that are already sitting within my computer, like this one here. But the interest I have got now is to introduce two data sets, one called Ideal1 and another one called Ideal2, which are data sets from the same cattle study I mentioned. So I've got them stored online on my GitHub, and that's what I'm trying to import here. As Ideal1 and Ideal2, and I can actually do ideal read underscore CSV and read underscore CSV, which is great in that now it will be invited into my console as a data set that is recognized as a table, which is the language of tables that is used within TidyVerse. So now, why that is what that might be useful is if I do now Ideal one and look at that data set, you see is without even writing head of Ideal one, I get, it tells me it's a table, it contains 30 rows of data and 8 columns of information as well. And it tells me that out of those 30, I've just been seen 10 and 20 more rows are there. And these should be 8 columns of data. And you could do that again for Ideal 2. So the beauty of inviting the dataset as an ideal underscore, I mean, as a read underscore CSV, it allows you to get a table that is much easier to deal with, and it'll give you like the header without necessarily having to write head ideal 1 or head ideal 2. So this second one, which is ideal 2, it has visit ID, it has 270 rows of data, 9 columns of variables. And the information, if you see what you've got in Ideal 1 and Ideal 2, you see that you have got CAF ID here. You have also got CAF ID in Ideal 1. Ideal 2 has got visit ID. This does not have visit ID. It's the same number of CAFs, but because you're doing longitudinal study where you have more than one entry per animal, Ideal 2 is that longitudinal data set, whereas Ideal 1 here is that data set that has things that don't change over time. So for instance, the CAF date of birth, which is given as CADOB, that will not change over time. So the location, so CAF sex and the education level of the farmer, and the initial weight at recruitment, which is provided there. So the idea for this is I wanted to show you how to have this kind of easy way working with data. So previously, if you're using like base R functions to say select or find only a number of animals that meet a certain condition, or select number of columns would have been a longer code, but with TidyVerse that's not hard. What you do is, I know I have take for instance, I want to join these two data sets, and I know that they have got a CAF ID that is common, which is a unique identifier within the two data sets. So what I'm going to do here is I'll say I would like to take 2 columns here. So I'm interested in the column of CAF ID and also the column of CAF Yeah, just calf ID and calf date of birth. Those are the two columns I'm interested in. So to select those two columns, you actually use the function select. So here I say I'm forming a new object ideal 1A, and it picks from ideal 1. So I pick the data set ideal 1, and then you pipe these signs here are referred to as piping, which you can read as then. So ideal 1, if I get ideal 1, then do what? So ideal 1, then select for me two variables, which is calf ID and calf date of birth, and then join it with ideal 2, which is this whole data set here. And I want to join with ideal 2 here, and the common unique identifier for the two data sets is the calf ID. So the calf ID on ideal 1 and calf ID on ideal 2 are the same. And then after you have completed that process, then mutate for me. And mutate here means you create a new variable. What you'd have done before would be, say, I want to create a new variable of ideal 2A, and I would say a new variable of ideal 2A, and I want to call it, say, visit date, like that. So whatever I give that information to, that will have been made into a new variable. But in the case of TidyVerse, that has been replaced by the function mutate. So I say mutate is create for me a new column, a new variable, and that variable, I'm calling it visit date. And then what is visit date? I want visit date to come to this figure here. I want the column visit date, but I want you to recognize that in the format of a day, month, and year. So this function of day, month, and year comes from the library Lubridate, which is able to coerce variables into dates. So here I've chosen one of the date formats, which is day, month, and year. And so I say I want to form a new visit date, which is equal to day, month, year. Take the format from Lubridate of visit date. So it's going to convert this, and then also do for me the same thing, but for calf ID, which would be within ideal 1 right here, and also make it a date function. I mean a date variable. So if I pick this and I run it so far, and I looked at ideal 1A, then you see the change of the calf date of birth now is reading as 2007, 11/03, and that appears slightly different from how it was reading here, but it's now recognized as a date variable within the table. So if you look at calf date of birth, the variable is now indicated as a date. So that's important, because then I can do things, or I can instruct R to get me what is the age of a calf every single time by doing the subtraction of when the animal is visited during the study and its date of birth, and that will give me the age of the animal in days. So that's what you've done here. You say, okay, I would like to mutate and form a new column called age in days, which is a visit date minus calf date of birth, which I had already indicated in the line before. Those should be treated as dates. And then after you've completed that, so if I run that again, and then I do ideal 1A, then I have got this whole data set of 270 of 11 variables, but my interest is only to do with, say, 5 or 6 of those variables, and I can select which those variables are. So after you've completed that, then select calf ID, age in days, weight, the radius, strongile eggs, which is what I do now. If I run that and I look at ideal 1 again, ideal 1A, then I see I have selected the columns of interest. There are 5 of them, but I have remained with the 270 rows of data. Okay, so, and if I wanted to say, look at that information arranged by calf ID and aging days, then I would include this. So if I run the entire thing now, it is going to arrange my data set such that I have the calf ID, so the lowest calf ID, then followed by that one, and also arranged by age in days. So that way, I have just been able to manipulate my 270 rows of data, 11 columns of data. I have joined them together as two data sets using a unique identifier, which is calf ID, and I've been able to select the columns of interest, and also have been able to use those columns to create a new column called age in days, which captures how old the animal was and what was the weight of the animal and its infection status. That's sort of a quick introduction to the way you can use TidyVerse to do a series of things that can be useful for your data set. Okay. So the other thing I wanted to sort of introduce you to a number of the functions within TidyVerse. So far we have used select, which is what you're using to get columns of data. We can use filter, and filter is used to select certain conditions. So if I only wanted to have male calves, then I would use filter. If I wanted to only have animals that are above 30 days old, then I can use a filter, and you make that condition. So that's a quick introduction to select and filter from TidyVerse. Okay. So the other thing I wanted to, in understanding how we use TidyVerse, let's create a new example of a data set. So before we imported a data set called the ideal 1 and ideal 2. Now I want to create a new data set, and I'm going to call it favorite team. And the idea here is to create a favorite team of 3 of my friends, Laura, Joseph, and Raisha. And each of them have 2 teams. They have a favorite team A and a favorite team B. And then I also have some information about the number of trophies each of their teams has won. So I could create a whole new data set from the beginning by saying I want to create a new object called favorite team, and I want to create a table. So the way to create a table is to use a function called table, which recognizes whatever I give it, I want you to make for me a table. And I have 3 columns of data. I have a name, I have football team A, and have football team B. And I want to fill in data set. The first row of data will be filled by Laura, Joseph, Elisha, with their first team A getting 10, 5, and 9 respectively trophies, and team B getting 6, 5, and 3. So if I was to run that, I have run that little code, and how does it look like? It says now I have got a table of 3 by 3 that has a name, football team A and football team B, and that has Laura, Joseph, and Elisha, and the number of trophies each of them has won. So to give you an example of, how do you, if you wanted to manipulate this data such that it becomes a tidy data set, you could do one function called pivot longer, which also comes from the TidyVerse. And the idea of pivot longer is to decrease the number of columns and increase the number of rows. Basically, it lengthens the data. It transforms the data into a long format. That's why it's referred to as pivot longer. So the idea here is I know that each of these persons here has got 2 teams, a favorite team A and a favorite team B. And I would like to have a column that just tells me the football team, and another column that tells me the number of trophies each of those teams has won. And so the way to do that is to say, well, I have got my first object called favorite team. Then on the favorite team, do a pivot longer, and I want you to not deal with the name. So don't try and lengthen the name, or at least break down the name. What I want you to do is get for me names into a new variable called a football team, and the values of these values here, which I said is a cell, I want you to put them in a new column called trophies. So that's what you do. So if you did that, and then you looked at the result of that, is that now we have changed. And instead of having a football team A and B as columns, now we have them for each person. Laura has football team A that got 10 trophies already. Team B has 6 trophies, Joseph has 5 trophies, and Team B has 5 trophies, and so on. So that's the way you use pivot longer to convert your data set in a way that is much easier to read. Now, if the data set was sitting in this manner, and perhaps what you are interested in was an analysis of the number of trophies, average number of trophies each team, football team A selected had, then this might be a better way of having the data set appearing. So for you to convert from this kind of data set into this kind of data set, you might need to use the pivot wider, which complements the pivot longer, and that you can go ahead and see how that looks like from your from your console or from your work. Okay, so let me just get back to this. What if you look carefully at this data set, you see that the name, the football team, and trophies, there's some redundancy in it. For instance, there is absolutely no reason to keep repeating football team A and football team B. You could actually just have football team and have A and B. So in R and within the TidyVerse, it's possible for you to remove this bit here. You basically can look at a string like football team A and remove a bit of that you'd want to remove and only remain with A. And the way to do that is, again, I have got my football team. I make the pivot longer, which is the code we used before. And then I say, make for me a new column. And I give the new column the same old name. And this case, I want you to gsub, and gsub is a function that replaces all the matches of a pattern in a string. So remember here, the pattern that you want to remove is anything that is football team A underscore. So I say that create for me a new column football team, and it's going to use the function of gsub to remove anything that looks like football team underscore, and then return for me that, and replace it with nothing. So if you do that, what you see is now you have got a football team, and you don't have those strings of football team underscore that were there before. So that's another really easy, nice function within the TidyVerse that allows you to deal with strings. In fact, by removing anything that is matching as per your as what you'd be interested in. And you could go ahead and again do like we've done before with the curve ID, with the curve data set. You could say, I want make it pivot longer, remove the redundancy of football team, but also arrange for me by name, and secondly, by football team. The same way we have done in Excel, like ascending and descending. So if you run that, the result of what you get is now the names have been arranged according to alphabetical order, and Elisha is the first, and before we were seeing Laura as the first. Okay. Great. So maybe we move on to another function that might be of interest for you as you deal with data sets. So it's called separate. And here I have got an existing data set within my folder. I'm calling that data set as households. And if I look at households and I select a number of columns, a number of rows, and number of columns, and run that and look at how does household look like. If I run that, that's how it looks like. So we have got a data set that has a 5x3, has a household ID, has an interview date, and has GPS coordinates. And the way we look at GPS coordinates, we have a longitude, a latitude, and the altitude. And what has happened is that in the downloading of the data set from whatever application you are using, the GPS coordinates are here. So we have got the 1.6, 36.7, and 557, and they have been separated not by a column, they're separated by a space here. So if you wanted to say, I want the latitude, longitude, and the height to be in each of them on a separate column, it's possible to do that using, as the name suggests, the separate function. So the work of the separate function is to split a single variable to several variables. And in this case, again, I take my data set which is now referred to as households. And I say then separate for me. And in this case, I'm interested in separating this column called GPS coordinates, and I'm going to separate it into a longitude, a latitude, and elevation. And those are the new column names that I'm going to put in. And the way to know where to put longitude, latitude, and elevation is to look at this column here and use this space as the separator. So at the moment, this is the separator. I want to replace that by a column. So I'll say the separator here is the space. And you can see here, I've provided a space. So now if you run that, what you see is you've got the household ID and you've got the interview, and you've got the interview date, the longitude, the latitude, and the elevation. And that's how you use the separate. So the thing to note is that in your notes, the ones that you have access to, all those codes are provided. So this is just to allow you to be able to follow the work as I was creating the slides through this RMD. Okay. And what you do, you can also undo. So here we have separated the GPS coordinates. You can unite them, and you should go and look at how do you use unite as a function. So far, we have introduced a few things like importing data, although I didn't tell you importing data. Like one good example is if the data sits within your working directory, you could actually just invite it into your console using this function of read, if it's a CSV, read underscore CSV, and that will read the data into your console as a table. Otherwise, you could also use read.csv, and that will be invited as a data frame. And there is a slight difference in how the two of them look like. So in this case, I'm interested in getting some data set called dog cohort demographics.csv that sits within a folder called data that's within my working directory. And I'm going to give it a new name called dog demography. So if I do that, and then I look at dog demography, it tells me I've got 1,207 rows of data, and I've got 11 variables. And if I wanted to see how they're looking like, I could just take the first three columns, the first three rows of data. It tells me it has an int date, has all these different variable names, which you can find out, you sort of go to a data dictionary and find out what do they mean. And that data dictionary will be created by the person who collected the data. So in this case, I want to show you some additional things that you can do with the data. So for instance, you see we have got this kind of dates. They're not, this kind of variable names, they're not intuitive. You can't tell exactly what they mean. So like, what is int date? Perhaps you might want to rename int date into interview date. So the way to do that, you could come in and say, I have got a data set, it's called .demography, it's the same name I had given before, but I want to name or to rename variables within the dog demography as this. So the first variable I want to rename is int date, which was here. And I want that new variable to be called interview date. Household ID, like that, I'd like it to be a proper household ID. Own dogs, all these data variables, you sort of can give them as a different name. And if you run that, then and look at how does your dog demography look like. Now you see that the data set reads with a new names here. So interview date, which was formerly int date, household ID, village ID, and on and on. So that kind of renaming can help you with your analysis of the set. So the other thing that I wanted to mention is that let's take the example of this data set called dog demography, and I'm going to make sure it's available right here. Okay. So if I run it, that's the data set right there. So quick introduction to the data set. So we have got an interview date, you have got a household ID, you have got a village ID, you have got household members, and whether each of those households, like does this household, how many people are in that household? And here the answer is 4. Do they own dogs? The answer is no, because they have a 0. But if you look at household ID 13 to 24, 3, they have 9 household members and they have 1 dog. Okay, so supposing you are interested in doing some summary of, say, the number of dogs you have got per village. So you could say, I want out of the dog demography, group by. So the idea of group by is I want to take one column and I want to group my analysis based on the values of that column. So in this case, each number here represents a name of a village. So I would say I want to group by village ID to find out how many dogs in total do you have in village 13 and how many dogs in total do you have in village 2. So that's what you're doing here. You say, I'd like to summarize by village ID and know how many entries we have got for each of those villages. So here, if I run it and I print it, it tells me that we had a total of 1,207 rows of data. Now we know that village number 2 has 158, village number 3, 40, and in total, that's what you've got. So looked at, we have 10 villages and the number of count of entries they have got. And the code to do that is to use group by and summarize like that. And then you sort of could go ahead and look at consistency of the data. I mentioned earlier on that you could be interested in finding rows of data that meet a certain condition. And if you were to do that, you'd require to use a filter. So in this case, I would want to get the same data set called dog demography. But in this case, I want to filter the adult dogs and puppies owned. Their sum must be equal to numbers of dog owned. So here, if you're collecting data, the way this data was collected is that the first question you ask, how many adult dogs have you got? And how many puppies have you got? And then how many total number of dogs have you got? So sometimes there could be inconsistency where someone says, I have 3 adult dogs, I have 2 puppies, and I have 7 dogs instead of 6. So you could look for consistency within your data by using this kind of thing and say, look, I want only to get rows of data that meet this condition, that an addition of the adult dog and the puppy's dog owned is equal to the variable of number of dogs owned. So take the example of here, 1324-3, that household. They say they own dogs. Yes, they have got the number of dogs owned is 1, and they have also got a number, and they also have got at least adult dogs of 1. So if this was 1 and these were 2, then that would not have been a consistent data set. And then you can say, out of that, also select for me several of those variables, as I had indicated before. So you could check for consistency in that way. And another really good example here is what I'm providing here. So here we are looking at, I've said, okay, for dog demography, I want you to group by 3 things: number of dogs, adult dogs owned and puppies owned, and select for me just the number of dogs owned, puppies owned, and numbers of dogs owned, and then only give me what is distinct. So in this case, we are looking at the number of dogs owned is equal to 1, which is basically 1 plus 0, or is equal to 2 because it's 1 plus 1 is equal to 2, like that. So you sort of can use that as well to look at data consistency within your work. The other thing is you could say, okay, I want to count the number of dog bites that happened in the past month, and then you're using dog bites past month, which is a variable within your data set, and getting a count. Again, using that nice function I mentioned before called group by. So what you see in this data set when I run it is that we have an interesting information here. So 1205 of the households don't own a dog, have no dog bites reported in the past 1 month, and 1 has reported 1, and 1 has reported 99. Now, in the way this data was collected, 99 actually means was not done. yeah, not done, but it's presented the dataset as 99. So one of the ways in which you could deal with that is to say, I would want to remove anything that is 99 and say it's not applicable. So one of the ways to do that is say, I have got dog demography, my dataset, and then mutate for me and say if a new thing called dog bite past month, which is these values here, and say if dog bite past month has any value as 99, return for me an NA, otherwise return for me dog bites past month. So that sort of does the miracle, or that's the magic. And if you are interested, say, in knowing whether it's true or false, then you could also say, I want to create a new column called dog bites past month new, and I want it to be a logical and dog bites past month, a logical of that. And if you run that information right there, and you printed dog demography, then I want to print the information grouping by the new variables I have just created, which will be print dog demographic group by the new variable I created, and then summarize for me the count. Then you see the answer will be that. So you false, meaning they never had any bite reported, and true, one of them, and the 99 has since been converted into an NA. Okay. Right, so let me go back now to my other slides, see where we are. Okay. Sorry. Okay. So we have looked at all these pivot longer, pivot wider. We have looked at mutating, how to separate, which I showed you on the console there from RStudio. And all those data sets are for you. Importing data sets, if it exists within your working folder, you can just invite it as it is. And if it's, you can rename your sample data sets. You could also summarize them. You could do the filter, as we have talked about. You can also get the distinct, and in this case, the distinct finds only unique values. So that's presenting unique values. And you can check for consistency here. We were using, the number of bytes in the past month. Yeah, so the next bit of it is data maintenance. You know that your database is a logical construct. The core of the data is that you may want to maintain and validate. And really important for data maintenance is to make sure that it's not, you don't have redundancies in it, but also that where possible, you have relational data sets like CAF, ideal 1 and ideal 2 relational databases. So there was a unique identifier in CAF in the first data set that you use to merge the second data set. Again, to emphasize really redundancy in your data sets, both for space but also for ease of work. And you can, break your data into separate tables that follow the logic of the data, but you need to have clear identifiers. In the case of ID1 and ID2, we had an identifier that we referred to as CAF ID. And that's what you use to break it into these logical tables. And the way those logical tables are placed sometimes within a software like Microsoft Access or SQL databases makes it pretty easy for you to analyze and work with. Okay. Let me sort of just spend a minute talking about making relational databases or relational tables. So if you think of the data set that has ideal 2 that has a follow-up information, we might want to break it into a table at the level of curves, which will be values and characteristics of curves that do not change. So like ideal 1 is one that contains sex, contains date of birth, it contains the education level of the farmer. So all those will not change. And then you have a table that has things that change, like the infection status. That's anything that happens over longitudinal time or follow-up events, those would change, or your weight, the weight of the animal will change. So those would be in a separate table. And then once you have got them in those separate tables, you could analyze them as that. You could clean each table, and then merge them, or you could also merge them and clean them together. So to give the example is the initial data set that I was talking about has CAF ID, CAF sex, sublocation, CAF date of birth, recruitment rate, those do not change. Whereas the ones that has, the many variables and long number of rows, those ones have got things that change, like when are animals visited, the weight will keep changing, the infection status, that will also keep changing. And you could join the two data sets now using, as I was showed you before, you were saying, I want the first data set, which is CAF init, and I want to join it together with the follow-up and the unique identifier, in this case is the CAF ID. And then you could also, again, use the same kind of analysis that you're doing before with the dog bites by grouping by, and you don't have only to group by one variable. You can group by several variables. Like in this case, we're grouping by each CALF ID, the visit ID, but also the status, and then you can do a count of that. And the beauty is that to move now from that manipulation into, like graphical exploration is really easy. So in this case, I'm using a function of a package called ggplot2, and it's called ggplot. And here I'm saying I'd like to take the data set called calves initial. And then the aesthetic of it is on the x-axis. I would want to have recruitment weight. And then I would want to see the histogram of that and label the x-axis as weight in kgs, the y-axis as count, and then can change the way the plot looks by having a black and white theme, which is theme underscore black and white. And the axes that are going to be on the x-axis, I want them to be of the size 20, and those that are on the y-axis to be on the size 20, and the element text to be bigger at 24. So what you get out of that is there. So the x-axis, this is what I was changing in terms of sizes, and then I said I want the x-axis to be the weight in kgs, and here to be the count, and that gives you just a nice quick histogram of only a few cows. So it's not a very beautiful histogram because we're only dealing with 30 entries here. Okay. So you'll be doing a tutorial called tutorial 5. And to do that tutorial, I wanted to introduce you to some concept about correction tables. So sometimes you could start a data set like this one, again, creating a data set of columns of country, continent, and count. And it's taking, Kenya is in the African continent. There are 23 things that you're counting of Kenya, Uganda, Africa, 31. But then you see an error in entry. You did not write Uganda, you possibly wrote Uganda. So you might want to correct this. It's important to know how you fix your data sets. The best way to do it is to use a table. So you could, because it respects the original data, it records your decision, is transparent to yourself and others. It's not just something that you did and went and changed the original file without someone who comes after you might never know what you did. So in this case, we know that what you have got as a country is Uganda. That's the error, and you want to patch it with something called Uganda. So you sort of can create that CSV outside of R or within R, and know that that's what you're going to use to patch. And the way to patch it is you want to fix the problem as far upstream as is possible, not on the actual data set that you're dealing with. And if you join the two tables, you could tell that you have got Uganda, the count, but the patch here is saying it's supposed to be Uganda. You've got the codes as well. So you could then say, I want to patch tab, that's your data set, and I want to mutate and create a new country where, if else, if it's not in the patch country, if it's patch country, so let me show you a minute. So if you look at this column here, it has got NAs. Now, R understands NA, so it can ask us a logical question, is NA? So R, examines that value and says, is it an NA? So this is what you're trying to use here. So you're saying if it's NA, if it meets that condition, then return for me what is written here as Kenya, Uganda, what is written here, Kenya, Uganda, Vietnam. But if it's not NA, return for me this. So that's what is written up here. So if it's not, return for me the character that is within the patch country, which is the dataset that you're dealing with. And then you can also remove it. And what you end up with is now a clean data set that has rectified Uganda, and you did not need to do it at the actual data set. You sort of did it with codes and using a table. I think one thing to note always is that R likes to convert characters to factors. Factors can be useful, but obviously can be confusing. But be aware of this possible problem. And also, you possibly don't want to say you have saved information about gender as 1 and 2, and then you went to do, say, a summary of that, and you found that it has given you the mean of 1 and 2, the number of 1 and 2s within your dataset, because you do need to indicate to R exactly how shall it treat the column of interest. And that's really important, particularly for your analysis. I think the other key thing to mention as I come to a close is try always not to touch your original data. Use scripts to make changes of your data, because you can follow what happened in scripts. After you change your original data, like within an Excel file or within a Microsoft Access, it's really difficult to know who did what when. And don't be afraid, obviously, to play, experiment, and probe your data. You touch other data, see the patterns it's giving you. That kind of exploration is really important before you can get onto your key analysis of interest. So in summary, I think I encourage you to go to Tidyverse, look at the way you use pivot longer, pivot wider, separate, unite, the select, filter, group by, summarize, arrange, join, mutate. All those are really easy to use and can make your work extremely easy or fast within the use of R. And also remember the piping, that then thing, because it's really useful and makes working with databases pretty easy. Okay, so in summary, let the computer serve you, input what you want to input, manage it in a tidy form that is efficient and logical, output in the way that you want the output to be aggressive about exploring and questioning and cleaning, and a lot of practice is needed. And after you're comfortable with it, just saves you a lot of time. Okay, thank you.